Congruence proofs always look more or less like this. They've always got these three lines here. That means congruent. This is about proving that triangles are congruent to each other, so that's why there are these little triangle symbols here. The points out of which the triangle is made are these in each case. That's just the abbreviation for the word therefore. And preceding your conclusion, this last line is your conclusion, you always have to make three statements. Sometimes those statements are called SSS, sometimes they're called RHS, sometimes they're called SAS, and sometimes they're called AAS. So by coincidence, there's always three letters in those abbreviations, that's why there's always three lines. So that's what a congruence proof looks like, but what is a congruence proof actually all about? Well, basically congruent triangles are triangles that are exactly the same. So if I give you that this is the center of a circle, which I often do by putting the word O there, and let's say, in fact that's all I need to tell you. If that's the center of the circle, then, and let's say we're going to have some triangles here. This is called A, it's called O, and that's B, and this is X and Y. Then I can be sure that AO is equal to OY because they're both radiuses of the same circle. I can be sure that OB is equal to OX because they're both radiuses of the same circle. And I can be sure that AOB is equal to XOY because of a year 7 principle about crisscrossing lines, namely that the angles they create are vertically opposite. So here are my three statements. But for me it's, and so therefore you can be sure that they're congruent. So therefore AOB triangle is congruent to XOY congruent. That's one of 4 ways to prove it. I covered a side being equal to side, a side being equal to a side, and an angle being equal to an angle, and therefore they're congruent by the SAS test. When you use the SAS test, just have to do a quick check. Make sure the angle you used was in between the sides you used. I used this side, and the angle I used was in between. So that is good to go. I'll give you an example of another use of a circle. I'm going to prove that this triangle here is congruent to this triangle here. Okay, now I just drew in right angle symbols there. Even if they hadn't been drawn in, you should know, especially if you're in year 11, that those right angles can be drawn in because this is a radius meeting a tangent. At least if I draw that as an O, you can be sure that's a radius. When a tangent meets a radius, remember a tangent is a line which just grazes the circle once, you always get a right angle. So, okay, so here I go. Let's put some letters on. So, OB equals OC because they're radiuses of the circle. Also, angle ABO is equal to angle ACO because they're both equal to 90. And the reason is tangent and a radius. And finally, AO equals AO because it's the same join in 2 different triangles. The abbreviation for that principle is just common. In other words, that stretch is common to both triangles. And we're done. So therefore, ABO triangle is congruent to ACO triangle. Now we covered a side we covered a right angle, and we covered a... Oh, sorry. We covered a side. Here were the sides. We covered a longest side in each triangle, and we covered a right angle. Special term for that is RHS. That means you talked about a random side, you talked about a longest side, namely the hypotenuse, and you covered a right angle. So that's the RHS test. In order to be able to conclude that things are equal to things, to form your congruence proof, you need to have extremely good knowledge of the properties of shapes. So if I tell you that this is a parallelogram, so this is given, your knowledge should be given good enough to conclude that that's equal to that, and that that's equal to that, because the diagonals of a parallelogram bisect each other. So just from my knowledge that it's a parallelogram, I'd say AE equals EC, and DE equals EB. And my reason for both is that the diagonals of a parallelogram bisect each other. I just need one more thing. Remember, these always have 3 lines. Why don't we say... let's say I now also tell you that that's equal to that. Well, here's a classic little reason where you just say that something was given. So AD equals BC. So therefore we covered a side, we covered a side, we covered a side. So therefore AED triangle is congruent to BEC triangle by the SSS test that I covered at the start of this video. The final possibility for proving triangles are congruent means you need to cover 2 angles and 1 side. So what's an example of that? Well, this is some Year 11 circle geometry knowledge. Let's say you have a butterfly shape there. Well, Year 11's, and that's A, B, C, D, E. Now, Year 11s should know that DAE angle is equal to EBC angle. In other words, that's equal to that. Why is that? Because, well, the technical term is angles in same segment. What else could we say? We could say that that's equal to that. So in other words, AED is equal to BEC angle. That's vertically opposite. And finally, let's say that this is given equal to that. So AE is equal to EB. That's given. So therefore, triangle AED is congruent to triangle BEC by AAS. Whenever you use AAS, you need to be careful. You need to make sure that the side you use is in the same relative position to the angles in each triangle. In this case it was. The side I used was in between the 2 angles I used, whether it was the left triangle or the right angle triangle. So therefore AAS is sweet. SSS is probably the simplest. You don't really need to think hard for that. SAS does require care. The angle needs to be in between the 2 sides you use. AAS requires care. The side you use must be in the same relative position to the angles. Doesn't necessarily need to be in between them. If it's opposite one angle, it needs to be opposite the same angle in the other one. If it's between the angles in one, it needs to be between the angles in the other. Finally, RHS requires care because you need to make sure that one of the sides you're using is the longest side in the triangle. That's when you got to call it h. These examples demonstrate how much geometry knowledge you need to have. Simply by virtue of being shown that this was being told that this was a parallelogram, I could conclude that that was equal to that. And you've obviously got to have very good knowledge about circles, because circles are a classic way of indirectly telling you that one thing must be equal to another. So for example, in this first one, I knew that that was equal to that because they're both radiuses. And in this case, even without that needing to be given, I knew that that and that must meet at a right angle, because that's what tangents and radiuses do.